Hello everyone, it's September 26th. Let's do this decoded string at index. You're given an encoded string S to decode the string to a tape. The encoded string is read one character at a time, and the following steps are taken. If the character read is a letter, that letter is written onto the tape. If the character read is a digit, the entire current tape is repeatedly written d-1 time. More times in total, so in total is d times. Given an integer k, return the kth letter in the decoded string. So for this, leet2 code 3, so we go leet2, so repeat it one more time, and then code, then leetcode will repeat it 2 more times. So we find the 10th. S length is 100. Okay, that. A is repeated. So yes, repeated 2 times. Then 3 times. Then 2. So 2 times, 3 times, 4 times. Yeah. Oh, Jesus. S starts with a letter. A guarantee that k is less than or equal to the length of the decoded string. The decoded string is guaranteed to have less than 2 to the 63. Yeah, that's just stupid. Well, of course you cannot just go ahead and do it. You have to compute, right? So yes, we have, some string and a number, right? And then some other string or no string with another number, okay? So basically, if we say it's going to be S1, D1, S2, D2, S3, D3, it's going to be like that. So it's going to be S1, D1 times, and S2, and the whole thing, D2 times, S3, whole thing, D3 times. Okay, then we need to find the pattern. Okay, so basically, and you're given a k, right? You're given a k. You're given a k, so if I go, if k is within S1, then we get it, right? No worry. And after S1 done, k is not in there, then we do a D. So we know S1 has multiplied D1 times, okay? Then we check if k is in there. If k is in there, then we can use mod, right, to get it. And then we go back to, so now this, however many this one is, right? Now we have S2. So if the k is inside S2, then we get it. If k is not inside S2, then we'll have this and S2, right? So basically we can say the base is this and this, right? Then we multiply by D2. That's the total. And we say if it's in there. If it's in there, we are going to, maybe we should do this like a recursion. Can we do this recursion wise? How do we do this recursion wise? So every function we know So when we pass the next, we know the length. Okay, we know the length. And then we have the current starting point, S2, right? Starting point. And then it doesn't matter what it is. We just have a length. That way go. And then if it's in there, we do. If it's not in there, we do the length plus this, that's the unit. Then we do mod. If after mod is landing S2, then we go. If it's not landing here, right? Then we know which position it lands. Then we return that position, okay? Return that position to the previous function. The previous function is dealing with this repeats, right? Now we have this position in the previous one. Now in the previous one, I can check, right? I can check. So the previous one also has a length and some S1, right? Or we can say SK, then previous SK minus 1. Then I tell you, right, that this repeats what I get in this repeat is some position, right? Some position in this entire repeats. Wait, hold a second. In this entire repeats, yes, this entire repeats in certain position in this entire repeats. So in here, I have this position that we need to say if it's in here, it's in here. Maybe we can do recursion for this. Maybe. It's not trivial. Okay. So this is decode. I need another function which will return the position. What will this function return? Interesting. What is it going to return? What if it finds, right? What if it finds? So we should return. Ooh, this return value is tough. We're gonna return negative. Okay. Okay, so we say private int because solve pre-len. I need a previous length, current index. Okay. Then probably need K. It's not really K, so I have the pre-length. It's larger than the previous length, right? That's why we go here. Alright, maybe I can do K. Hold on. Right? And now I can say this K equals K. Okay, so and S. Okay, then we can go just go through and see if it's within K. If it's within K, because the K definitely is larger, right? So when this function is called, k must be larger than pre-len. Otherwise, we would have solved it in the previous round of calling solve. All right, so now we need to know the current round, right? The current round. How many it's gonna be, right? How many it's gonna be. So what we're gonna do is for int I equals index I smaller than s dot length I plus plus int I how do I check if it's and can I say s dot charet I is larger or equal to a and s dot charet I is smaller or equal to z? Or do we have a smarter way to check Java check whether char is number? Wait, hold a second. A single digit. It has to be a single digit. Unicode and ASCII is different. Okay, I'll just use this, right? So let's make holy crap, can I just do this? As empty body, it doesn't want me to have empty body. But I really don't need a body. I might as well just use a while loop, right? I'm gonna say while I blah 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 I plus plus. Okay. So we just keep going until we either hit the end or hit whatever. Hit the first one, that's a digit. Okay, so now I point to the digit. And now I can say the total length of the I'm gonna say int len s, right? Len current s shall equal to I minus index. Is that right? 0, we can say 0, 1, 2, 3, 4. 4 minus 0, yes. So that's the current length, okay? And one more question. Java char2 int. Get numeric value. get numerical value. Okay, I'll use that. Okay, so current length, we can say int len currentness, len current repeat shall equal to pre-length plus this. Okay, len total, current total shall equal to pre-length plus len this. No, I already add them. Times character dot get numerical value s dot char at I. If right, we should say I is smaller than s dot length. If it is, then we do this. Otherwise, it's gonna be that. Okay. So now I have the total length. Then we say if k, okay, as the total length, and k is the kth one indexed. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, the 10th. So it's just the length, right? So if k is larger than len current total, then we know call solve. Pre-length will be the len current total, and then index is going to be, you probably need to do I plus 1 because I is pointing to the digit. So go to the next one. Okay, so this will return a value, right? This will return a value. So we're gonna say say what? So if k is larger than len, right? And then we need to do is no, hold on. Position. I need a position, right? I need a position. If k is larger, then it's not a u, right? And then if we call this shall return to me a position, right? A position or a character, a position or a character. So we need a position. We call it res. We say res equals this, right? We say if res is smaller than 0, intentionally, this means we found a character, return res. Okay, otherwise we have to keep going on and when they return the res. Otherwise, res is going to be, so we pass on to the next one, right? And the next one is trying to find where it's supposed to be, and find is inside. So this res is going to be inside the current len total, right? That makes sense? Actually, it doesn't make sense. We have the current len total, right? And then k is bigger than. Then I go to the next one, right? And I will repeat again. And then this might end up inside, the position might be end up inside my current land total, right? My current total. Yeah, that's what the position is supposed to be. It's somewhere in the current land total. Then I need to deal with it, right? I need to deal with it. Yeah, I set res, okay? Else I need to find the res. So k is smaller, right? K is smaller equal to total. Then do we have the position? Because the previous will tell me the position, right? What is this position? What is this res? Its position should be, because I am in this, right? We have the previous and I have this, and then added together, this is the current length, and then k is still larger, so we go to the next one, right? Now we go to the next one, we may repeat the whole thing. So like this. Yeah, just consider it's inside, right? It's inside. So we have this plus this, and then we do this plus this too, right? And then we will do a mod. Right, so we find out it's gonna land in, if it's landing here, then we're done. If it's landing here, which is the pre-length, the position inside the pre-length, right, which is just the size, right, the size. So when I return back, it's giving me the size. So how do I do this? I just need to, at this position, we need to do a mod, right? We need to do a mod on this, just like the mod. Oh, I think I know. So if this, else, rest read okay, right? If k is larger, then rest will be this. If this, return it. Otherwise, we go. Otherwise, rest equal to k. Now what we're gonna do is the k. It's in this total thing, right? So we have, we know it's this position. Then line current repeat, right? Line current repeat. Then we say int remainder shall equal to k mod len current repeat, not k, res, right? Mod len current repeat. Now we do the len current repeat. Now I know which position it is going to be, right? Which position is it going to be? Yeah, let's call this now res. Let's call this position. Okay, now we find out that. Now we need to know if it's inside this or inside this. Then we say if r is smaller or equal to pre-length, okay, then we return r. We return the pre-length because it's inside the previous length. It's not anything to do with me. It has to go to the previous one, right? Have to go to the previous one. Else, if it's not in the pre-length, then it's inside my current, right? It's inside my current. Then we can return the current s, right? In the current s, so it's larger than the pre-length, right? It's larger than pre-length. So I need to know. Let's say pre-length is, right? Let's say we have A, B, C, D, if that's the pre-length, and then E, F, G is the current. So it's 4, it's 5, right? And I need to know, I know this is index. So it shall be 5 minus pre-length, then index plus 5 minus pre-length minus 1, right? Because 5 minus pre-length is 4, 1, and then index plus, so it will be index. Or if I 6, then it will be this. So I think it shall be position minus pre-length, because it's larger than, right? Minus the pre-length. Once you minus, then you do index plus this minus 1. So we say s dot char at this char, but we'll do a negative. Okay. So eventually we will get to a point where, yeah, okay, so now we do this, then we just call solve. Pre-length start with 0, with no pre-length. Index start with 0. Alright, so we shall return char of this. Of course we do it negative. Oh, it's a return string. How do I turn it into a string? These are the basic things I just never remember. String dot value of, or char dot string. Dot value of. Okay. Gonna give this a shot. I'm not confident at all with this one. Yeah, just do this one. That is bonkers. That is bonkers. 111. 111. Oh, I might have to turn this into a char. Can I do that? Maybe 111 is O. Who knows? Oh, it is O. Yeah. Okay. How about we throw all of this in? Ugh. Ugh. Alright, this. Okay, so this k equal to 1. Okay. So we do solve 0, 0, right? We pre-length is 0, start with 0. I is 0, and it's good. So I plus equal to 1. So I become 1. Okay. So current length is 1. Okay. Current repeat is 1. Current total is going to be 2, because AA, right? Current total is 2. If k is larger than no, so position will equal to k, so position is 1. And current repeat is 1. So R is equal to 0, right? And R is equal to 0. And it's smaller or equal to pre-length. Huh. So we return R. That is a position, right? That is a position. Oh, hold a second. R is smaller or equal to pre-length. Yes, we shall return R. So we probably need to handle it on this side as well. When we get out, it's going to be in the first. R is inside the pre-length, right? R is inside the pre-length. We shall return the position. Yes, yes, that's correct. That is correct. We shall return the position. But that's how do we handle this? R is supposed to be the position, and R is equal to 0. So if R is line current repeat, right? Position and line current repeat. And then you know within the current repeat where it is going to be, right? You know where it is going to be. And then it's going to be somewhere here or somewhere here, right? So the pre-length, it depends on the pre-length, right? If pre-length is 0, yes. If pre-length is not 0, then I think it can do that. If R is smaller or equal to, if pre-length is 0, then I don't think you can do it that way. All right, if pre-length is 0, if pre-length is 0, if pre-length is not 0, then we have a pre to go back to. But if pre-length is 0, pre-length is 0, then R has to be larger or is equal to 0, right? Now what does it mean R is equal to 0? R is equal to 0 because pre-length is 0, right? If pre-length is 0 and R is equal to 0, that means, because you don't have a pre-length, that means you shall return the first one, right? Because yeah, okay, I think this is it, right? So we have a couple of things. If R smaller than this, right? And then we say if pre-length is equal to 0 and R is larger equal to 0, and then it's equal, right? So in that case, we shall return, because we have no pre-length and R is 0, which means the position divide is divided by this, right? Position is divided by this. So whatever it is, it divides. So it shall be the line current repeat, which is the line current S. It should be the end, right? The end of the current S. Yeah, because it divides. So it's either, no, there's no either. There's no either. If pre-length is larger than, we always go to the previous. If pre-length is 0, right, and R is 0, then the only possibility, because if wait, where is 0 appears? That would be 1, right? No, so this is one more thing you need to go through. So I have 4, right? If we position here, that's 1. Now 1, 2, 3, 4. This is where we have 0. So it is the last one. It is the last one. So if that position is the last char at the current s. So the last char at the current s, which basically shall be I minus 1, right? It's I minus 1. So return s dot char at I minus 1. Of course, we're doing negative. Right, position is the last char at the current s. I would never really change I, so we can do that. Otherwise, then we return this. Then we return this. So we add this line. Let's see if it works. So if this, we add this line. It works so far, but I feel like this one can do a lot. It can do a lot worse than this. Maybe we can do I don't know. Just give it a shot. Oh, string has length. Ah, that's fine. We just remove some. Ugh. That's not right. Ugh. Okay, it's not right. Yeah, let's investigate this one. Don't go too. Let's see. Oh, we probably don't even have that position. 2, right, times 3, 24. So maybe let's go 20. Hopefully it's wrong, so we can figure out. Oh, shoot. Yep, I'm doing this. Just see. I could have write it myself, but I'm kind of lazy. Nice, we hit one. Output OA. Expect, oh, 1, 2, 3. The third one, we got a third one wrong already. Nice. Good, the third one is this. Okay, once we found that, we can debug this. Yep. Okay, let's debug this. All right, what do we have? We have a string s a2b34. Okay, int k shall equal to 3. All right, now we do this is decode at index s and k. Yeah, let's run it. Good, it's wrong. So now let me write it out first. I need to write it out first. Let's see if the idea works. All right, so we have a2b34. Okay, then k is equal to 3. So first we have a, and then k is larger than that. Then we say AA, so the pre-length is going to be 2, right? AA, pre-length is 2. Now we go B. Okay, so the current length repeat shall be 3. Okay, and the total is going to be 9. Okay, so total is going to be 9 because I have this, and I have this. So the total is 9. Okay, then k is larger than the current total? No. So the position is equal to 3. Now r equal to position mod, we can write it out. The position is 3. Right, line current repeat is also 3. So this gives you r is 0. Okay, we say r is smaller equal to pre-length. No, the pre-length is this. R is 0. Yeah. Ooh, r is 0. Yeah, you do have to. If r is 0, hold on. So the current repeat is going to be a pre-length plus s, right? Current s. So, and now we say position is going to be on the entire thing, right? We have a position, and we do mod, and mod will land in any position. Yeah, that's not right, because the 0 is ending at this. Yeah. So it shall be r is remaining. So r is smaller and r is larger than 0. Right? Then in that case we return this. Okay? Actually we should do this one first. If r is equal to 0, shall return this. If r is equal to 0, which means you point into the end of s, right? If r is inside the pre-length, then we deal with it in the pre. Otherwise, if it's r is inside this, then we do position minus pre-length. You know what? I think this and this is exactly the same, so I don't have to do this. Right? I think this shall suffice. Yes, just give you B. Alright, let's try that. Let's try that. We have our test cases. Let's throw all of them in. All of them in. Okay. All right. All of them in. Jesus. Which one are you complaining about? I have no idea. Did all these one work? Nope. Huh. Oh yeah, that should not be position. right? That should not be position. I have r, which is a remainder, right? Which is remainder. And the remainder should be r, right? Minus technically, so r, we can do another mod, or we can do a, yeah, you know what? Screw this. This should be r. But if r, is smaller than r, if r is equal to 0, right? Yeah. We shall return minus s dot char at I minus 1. Easier. Okay, now we can try everything. Try everything. Oh my goodness. Which one? I returned 2. What the hell? 1, 2, 3, 4. The fourth one. The fourth one. 1, 2, 3, 4. Ugh. You're kidding me. I returned 2. Huh. That's very funny. That is very funny. It must be like somewhere there. It's just not right. I think this should be right, right? And this is wrong. Can we have a simpler one to, just to try? I don't know. We'll probably have to do the same thing. Yeah, let's just do this the same thing. We'll do all of this. But we'll remove the b. Okay. Throw it in. Yep. 1, 2, 3, 4. The fourth one. 2, 3. This one. All right. Let's see. We have a 2, 3, 4. Okay. And then k is equal to 4. So we have, a, and then we have AA, right? AA and 3. So the pre-length is 2. Current length, right? We have pre-length, current length is 0. So repeat is 2. And then length current total is I is smaller than s. I is pointing to this one. Current repeat length times 3, so it will be 6, right? So basically I have AA, AA, AA. Yeah, we have 6. Now we have a 4, right? And the position, oh, actually I don't even go to 4, right? I don't go to 4. What we have is k is 4. Current total is 6. Okay, it's larger than no. So position equal to 4. Okay, and then current repeat. So 4 mod current repeat, so equal to 0. All right. Oh, I is pointing to this one. Dart. dirt. Right? I is pointing to this one. And R is 0. Ugh. R is 0. R is 0. What does R0 mean? Well, R0 means it depends, right? R0 means it depends. So we probably have to go back to the previous one, right? We go back to the previous one. Because in the current one, so what we say is we have a pre-length, right? And then we have the current S. And then R is 0. We say we point to the end of current S. But that's if we have current S. Right? In this case, we don't have a current S. So we need to return to the previous one to see if they have a current S. Which means if R is equal to 0, there are two situations. One, if len current S is larger than 0, then perfect, right? We do that because we have a current S. If we don't, then we shall return R, which is return a 0. And then we'll go back to the previous one, right? Previous one is going to be AA, right? AA with a 2. So the current length, we have a current length. So that, is that right? Okay, that's correct. Let's go back to all our test cases. Man, this one is not, I'm pretty sure I'm using the wrong methods. That's why it would be so complicated. Oh, I think it might be right. All right, so let's write some comments here. And then these are pretty self-explanatory. All right, position. Found the character, yeah. And also, okay, we say it returns a non-negative, right? A non-negative integer if the case letter is not found in the current stretch of S. If the character we return the position to the previous round of recursion. Oh, sorry. If the case letter is found, we return the char, but in its negative version to separate, right? Separate from the other form of return value. That's that. So this is found, okay? So this means the position of the letter resides in the previous length, right? In the previous length. So we return the position to the previous recursion, right? So this, if there is a current stretch of S, the character must be the last character of the current stretch, right? If there is no current stretch, right, then we have to find, right, we have to find the letter in previous recursions. right, this means, what does this mean? This means the letter is within the current stretch, right? Within the current stretch of S. Okay, let's try. Oh my god, it was so easy, I guess. Oh no, I solved it last time. Dude, and it's not a nightmare, so oh my god, I solved it last time, I wasn't able to solve it this time. That's disheartening. That's very disheartening. And I got it wrong. Shoot, it gotta be a different method, right? This one is just too complicated. It doesn't feel right. It does not feel right. What was the... Yeah, I'm stuck with this recursion. Maybe recursion is not the way to go. Is there another method that you can think of? I mean, I can keep grow. How about, yeah, let's not think about recursion. Maybe recursion is, making things more complicated. I just think we keep things growing, okay? So we keep going, and then we can grow until a point where we can include the K, okay? So we know K will happen in this stretch. Okay, fine. And then what? It will happen in this stretch. Then we'll try to find like within where this is exactly the same method I have here, right? But it's wrong. Almost right, huh? Almost right. Yeah, but no, there's no such a thing as almost right. All right, we have to dig this. We have to dig this. Ugh, I hated it. How come I got it last time? This is always the most annoying part. You get it the previous time and you fail this time, and you can just guess, and then you have to wish. Oh, that's probably not even right. That's too much. You have to wish that it work, and you will find an error, and then Jesus correct. Okay. Ugh. That's really bad. Okay, I don't know. I don't know. Just take some guess. I don't know. Just throw them in, see if it's correct. Oh my goodness, they're all correct. Holy crap. Ugh. What did I do wrong? Output X, expected A. I don't want to analyze it. I just want to find it. I don't know. Expected A. Four. All right. Shoot. It's hard. I can't play this around. Yo, you gotta be kidding me. Everything is right except the first one. Holy crap. What type of edge case could it be? I don't know. I really have no clue. It's just not debuggable. Who says it's not debuggable? You want to debug it? It must be crazy if you want to debug this. Yeah, but I have no other way to know how this one, like why is this wrong? You can say I'm just curious. You know, very curious. And let's put, okay. All right. Okay, so current I index is 0, yes. and I is 3, 0, 1, 2, 3. Okay, let's move on. Current length is 3. Current repeat is 3. Current total should be 9. Right? And then k is larger, so I'm going to solve again. Current total 9. And index become 4. Right? 0, 1, 2, 3, 4. Okay. And 4. Current s is a 0. Current repeat is still 9. And then this shall be 9 times 7, right? 63. Okay. So when that happens, we will put I plus 1 in it. So it'll be this. And I incremented 2, so it's 5, 6, 7, 8. Okay. So current S is 3. It's understandable. Pre-length will be 66. That times 9. Yes, it's still smaller. There we go. Yeah, man, this is not gonna work. This is not gonna work. Now I already lost track, right? Index is 34. Oh. 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 Overflow. Overflow. Dude, overflow. I think you might overflow. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is fine. One, 2, 3, 4, 5, 6, 7, 8, 9. I don't even know where it is. It's okay. Yeah, I think you overflowed. Pre-length is this. Current length is this. And then we multiply. Hold on. Times this. What's SI? 53. You don't know where 53 is. I is 53. How about... Ugh, it doesn't tell you, huh? But it will be somewhere, right? Somewhere in there. And you multiply it. And it becomes smaller. You see that? Current length total becomes smaller. And then we can actually, we'll keep going on. Yeah. Okay, I think it might overflow. So if it overflow, that means this we need it to be long. This is fine. Linus is fine. This has to be long. This has to be long. position. Yeah, this has, because position, I mean, k is int. This is long. Well, actually, previous length can be long, right? So this has to be long, which means current rep is long. This has to be long, but the position is int. Position is int. No, position is long. Position is long, which means this has to be long, because position is the total, right? Where is it going to be? That's position. So position, and then this is going to be long. This is going to be long. So this has to be long. And then we do this, blah, blah, blah. And this is a long. But this is index, so it cannot be long. So we just cast it to int. Okay, let's, is it right? Yes, it's A. It's A. Oh my god. Oh my goodness. Should I say? Oh no, I wrote so many. Oh, screw me, man. I wrote so much and I didn't write anything here, so I have to change it again. Oh god. Alright, that's fine, that's fine, that's fine. It's a last push. We have a long. No, this is int. This one is long. This one is long. This one is long. Okay. And then blah blah blah. Nothing changed here. This is long. Nothing changed here, and we have to yeah, actually this is not right. This has to be doing this one. We have to do this. I have to do int. Okay. All right. How about now? Actually, I did both. It's actually the same thing. Huh. Hey, how come this one works? Dart. All right, int. I call that res equal to. We'll convert to int minus solve 0, 0. Okay. Oh. Do char. That's funny. And does not char, dude. You kidding me, man? You kidding me? Hold on. This is. I need. This is too bad a way to debug here. Let's put it back here. Oh my god, I didn't. This one took so long. All right. They have a lot of things. Oh, this should be long. And this is not right. This is not right. We have to int. Let's run this. 97. Char. Yep. What do you think? Do we need to do it this way? Maybe we don't. Is this one right? R. Yeah. Yeah, it might work. All right. Last push. Come on, last push. Haven't eaten yet. I need to eat. Come on. Come on, come on, come on. Show me, show me. Yes. All right. Let's go back to push all of this. Man, how did I solve it last time? This time I just struggle. All right. Let's go. Come on. Come on. Yes. Oh my God. Me God. Good performance, which means we are doing it the right way. But, me God. Ugh. 880. Took a lot of effort to get this one. The basic idea is recursion, right? At each level, we combine whatever length previously with the current stretch of S, and see if the kth letter is in the current it can be found, right? If not, we keep recursion. Otherwise, we rewind, right? Rewind the call stack to find where the kth letter is. I don't even know the runtime. I don't even care. But note, this is Java. Int can overflow. That's all I want to say. You can overflow. All right, let's just put this in and call it a day. Oh, jeez, man, that's another one. 27. Oh. All right, that'll be it. I think I'll check my previous solution, but yeah, that's basically it. All right, well, now